This is the test bench program which is showing for the replicatory counter. See the module. See here the module stimulus is given. Okay, module stimulus, then register clock, because of in the main program input is a clock, so register clock, then register reset, then wire, the output is Q 3:0. Then let us initiate the main top module of the program name is triple_carry_counter. Then instant name is R1. Then we given Q clock reset. Now first initially as same, you have to control the clock signal that drives the design block normally. So we have to initialize the clock. See here, we can write like this also, which I shown. Even you can write like that also. Even you can write like this also. You can write multiple initial, multiple always statement, but multiple initial in the sense within the initial again the one more initial should not come. As like example, if you want to say initial begin, say example initial begin, then again you may think initial begin, again you may think initial is like this. So you should not write this one. This is totally wrong. We should not write. So like this separately you can write. That is why as you can see initial only for clock signal we are initializing clock is equal to 0. Here we initialize. You can do like this also. Next after make initialization you have to generate the clock. So this is a better good idea. You can do like this better. Initial clock is equal to 0. Then always hash pi, for every pi screen times the clock will be inverted. So means the time period how much now? The clock time period is 10, one clock cycle. Now let us control the reset signal that drives the design block. So let us go for one more, once again initial here. So now initial begin, first start with reset. See here reset we are making 1 initial. We not specify anything here. The meaning is what is become as reset is 0. Reset is equal to 1 at what time? In the 0 actually. You see very important. When you are having multiple initial statements, all the delays will not be added cumulatively. Each and every initial statement, begin and whatever the delay is there, that much delay only will take. So like say example here one initial is there. Example I'm saying here one initial is there. Begin, then statements, end, again one more initial here. Here I written as something called as reset is equal to 1. If I write here reset is equal to 1, then you may think which is 0 delay, which is 1 delay. So like even this and this, there will be a contradiction will be there, that we'll see in the later in the program, sir. You may get doubt. So how we'll get all these things, sir? So now here what I will do, reset is 1 when 0. Next from 0 to 5. So this here the reset is 1, right? So here the reset is equal to 1 from what is the time delay? From 0 to 5 actually. That reset 1 is from 0 to 5. Not only 5, I can say even 0 to 15. Let me write as 0 to 15. Reset is 1 from 0 to 15. Right? Next, what will happen? Next here. Yes, next here. What happened? After 15, reset is equal to 0. From, it makes to what? From 15 to, that is the screen, 15 to 180. Next, correct? 15 to 180. 15 to 180. 15 to 180. 15 to 180. The resets become as 0. Next, same the way here. Reset is equal to 1 from 182 plus 10. What will do? 180, not 118, after 20 also. So what will happen now? Reset is equal to 1. Reset is equal to 1 after how much? 15 plus 10 we can say now. Now we can count the value, right? So let me write, that is, I think we may made mistake something. Yes, so 0 to 15. Next, from 15 to plus 180, right? Reset is equal to 0 from 15 to plus 180. Means 195. 15 to 195 because plus 180. There 180 is there, no? Up to 180 actually. I can say up to 180. This is fine. Next, reset is equal to 1 from 180 plus 15 is nothing but what? 195 actually. Correct? 195 to plus 10, 200 actually. Because after 10 here we are having it. So like this it will go. The finally we are having what is the simulation time here? The simulation total simulation time is how much? Simulation time is, what is the simulation time here? Any answer? Yes, it is 225. Because 15 plus 180 plus 10 plus 20. So 180, 195, 205 plus 20, 225. Now let me see. In this additionally we had like this initial, one more initial. If you want to monitor is nothing but simple. Later we said this is also called as system task function. This is a special function in the Verilog. It will display your, it will monitor any input or output get changes. That value will be printed in your system. Which are the values will be printed here? You can see $monitor, $time means your timing will be printed. Then output, the Q is equal to the Q value will be printed. These two here percentage D. This is nothing but simple your C program. The percentage D, this is what? It is a decimal value or integer value. So that value will be printed over there. So now what I will do, let me show the here how we'll get the time. This is the time. I'm going to show the value how we are going to get time. Next clock signal. I'm not going to show the clock signal. I'm going to show the reset time, reset, then Q. Time reset Q. Now let us see first 0. 0 time 0. What is the reset? Reset is at time 0. Reset is 1. Reset is 1. Then what will be Q? When reset is equal to 1, you need to reset. So Q will be 0. Next, when time is equal to after 0 up to 15, correct? Up to 15, the time is 15 here. So what will happen now here? So you may think I'm written directly 15, but the timing will be jumped from like every 5. That is the meaning of that, correct? See, why I am written every 5 here? Any answer? Not every 5 also, I may write as 10 better. Instead of that, I will write like this. Any answer? Why I am written like this? Because for every clock cycle is 10. Yes, clock cycle.
Is 10, sir.
Because clock cycle is 10. So this is, we can say each and every 10 time period, the value may change, right? So because your reset signal will change only during the clock cycle only. That is the reason I have written here. Now you can say at the time of 10, what is the reset value? Any idea? At time of 10, what will be the reset? Reset is still it is 1 only. Reset still it is 1 only. Reset is 1. What will be Q now? Still the Q is 0 only. Next, now come the time 20. What is the reset value? Tell me. What is the reset value at time 20?
0.
It is 0. You can see because after 15 screen time
0.
units, reset becomes 0. That is why it means 20. Means already reset is 0. So reset is 0. Then what is Q now? Yes, Q is 1 because the counter is started to count. So Q is 1 I'm getting. Next, at time 30, what will be now? What is the reset value? Time 30. Reset is 0 only. Now what is Q? 2. Yes, next time 40. Again, what will get? Reset is 0 only. Reset is 0. Then Q is 3. So it will go like this only up to till which time? You can see for every 10 this counting from where it's started to count at 20. Now you can say at 120, 10 or 11. I can say after 180. So what I will do, let me say here I will take as 180 here. Example. At the point of 180, what I'll get now? What is the reset? Reset becomes 1. Then what will become as Q? Q will become as 0. Sorry. Q is 1. Next, here I have 190 because 180 plus 10, 190. Then reset becomes as again 0. Then what is the value here? Any idea? Because of reset is 1. See, reset is 1, the Q will become 0. What is now here?
3.
How much?
3, sir.
How much value?
3.
3. How come 3? See here, at time 180, the reset is 1. When the reset is 1, the counter will get clear. So I'm getting 0. Next, at time of 190, in the sense you can see here, 180 is there plus 10. So your after 190, reset goes to 0. When the reset goes to 0, what will happen now? What is Q now? Previously, the Q was cleared as to 0. Means now the counter will be what? Again start to count. So I'll get as 1. So from here again I'll get 1, 2, 3 like this. So your counter will count up to where actually? Up to 171D the counter will count. Till here, till 170, the counter will count. How much? It doesn't know how much value. Till here, the last value of counter. Just lying on there. I doesn't know what value. Last value of counter. I'll say this is the last value of counter. It can be any value. After that, it will come like this. Then I can say at the time of 2:25, stop simulation. This is what will get happen normally. At the time of 120, we will get Q is equal to 11. At time of 120, Q is equal to 11. So I will write here at time of 120. You can see I am not written any value. Here the Q is equal to 11 actually. Here reset is 0. I'll get as Q is 11. Like this it will go. This is your simulation output window. Like this only we will get. So when you are doing the simulation, easily you can verify how you are getting the output. Any doubt in this? Understood? Is it clear?
Yes, sir.
I hope you understood this, right? So, like this only, now I can say you can write any test bench program for any program, right? This like this only you have to write. For all the programs or test benches has to be written like this only. So, only thing is you should think logically at what time. You have to think like, see, simply if I give, here you may think, simply if I give after 115 here in the instead of 180, you may think as 20. I will make reset is equal to 1. If I do like this, what will happen? The problem is the counter will not count completely. So you should allow the counter should complete completely in the sense you should keep reset value as long as period you have to keep. Then only you can. So very importantly, one more thing, you should not give more time period for clock signal always. See why? Because if you are making the always statement here, example, I'll say here, if I written like this example, always hash 200 clock is equal to not of clock. If I write like this, it will think. So the one clock period time is 400. Now what will happen here when I write automatically? What will happen here? The clock period time is 400, but all the operations will be complete within 400 itself. Now what will happen? Q value will not change at all. Why? Because the resets go 0, reset is 1, everything is happening between the one clock cycle itself. So see, this is your one clock cycle. So because whatever the resets getting happening 0 or 1, it will happen only during the edge of the cycle. Okay, which edge is it is a positive edge or the negative edge. So now you should make the clock signal is very, very small. So that is why I insisting you always the clock signal should be very, very small. That is the reason you may think the frequency should be very, very high. If you want to run any digital circuits, your frequency will be very large. It's very high in the sense, then the speed of the circuit will more fast will be there, because the frequency increases, time will get reduces. That is what you are. So thing what I can do. So this should not be written. Yes, this is wrong. You should not write. You should not use like this more periods. So use always like this only. This is better. I hope you understood this now. Is it clear?
Yes, sir.
Do you have any doubt, you peoples? Any more doubts? Still now, whatever we did today class. Okay, this is all about
Sir,
yes.
sir, and the reset is 0, sir, from 15 to 180, sir.
Yes, 15 to 180, the reset is 0.
In the table, sir, here you were written 180 equals 1, no, sir. Reset should be 0, no, sir.
This line we are saying reset is equal to 1. See here, 0
Yes.
to 15. Okay, from 15 to 180 means what is that timing you can add? I can say it is 195, no? 15 plus 180.
Yes,
195. So the time period I'm saying 15. So next up to 180. Next after some delay, I'm saying meaning is what? So 15 plus 180. That is the meaning of that. So you have to add the complete one. So that is the reason I'm written is 195 after 195. From 195 total time period. I'm saying from the total time period in the clock like this. Let me say here. See, when I draw like this clock period, when I draw. So this is 0, you consider. Next you can say this is considered as 15, this is considered as 15. Then you consider as this is 180. Now you see here plus 10 is there, no? Now after 15 plus 180 is how much? 195. So this is plus 180 means 195. So I'll get us here 180, 190, 195 here. So 15 to 195, the total is 180. So you are thinking here, oh, if you want write, you can write like this, 15 to 195 then. After 15 plus 180, so 195. That is the meaning of that. It is not the meaning of after 180. You should add cumulatively, you have to add the delay. So it is like a 195, you can say, 15 to 195. Is it clear now? Is it clear?
Yes, sir. Thank you, sir.
Yeah. Okay. So any more doubts? Okay. So this is all about today's class. So let's see in the next class.